Hello students, today's topic is emulsion and we discuss about what is emulsion and why we used an emulsion in pharmaceutical field. An emulsion is a thermodynamically unstable system containing a mixture of two or more immiscible liquids which is stabilized by the adding emulsifying agents are known as pharmaceutical emulsion. Phases, there is two phases in the emulsions. One is discontinuous phase and second is continuous phase. One liquid is present as a droplet distributed throughout the other liquids. ठीक है, dispersed liquid को हम क्या कहेंगे? Discontinuous phase या internal phase, whereas the dispersed medium is known as the external or continuous phase. ठीक है. Types of emulsion. What are the types of emulsion? First is oil in water, second is water in oil, and third option is multiple emulsions. The first oil in water type emulsion में क्या होगा? Oil droplet dispersed in water phase. And water in oil phase में emulsion में क्या होगा? Water droplet dispersed in oil phases. Multiple emulsions में भी दो रहते हैं, जैसे कि फर्स्ट इज वाटर इन वाटर एंड सेकेंड इज ऑयल इन ऑयल. ठीक है, जो वाटर इन वाटर रहते हैं वो वाटर इन ऑयल इमल्शन रहते हैं जो डिस्पर्स्ड होते हैं वाटर फेज में. ठीक है, बेसिकली वाटर इन वाटर इमल्शन टाइप इमल्शन कहाँ यूज होता है? हमारे इंजेक्टेबल फॉर्मेशंस में. साइजेस लिक्विड ऑफ ड्रॉपलेट्स कैसे डिफर करते हैं? टू टाइप्स के होते हैं, macro emulsion and micro emulsions. The macro emulsion size is 0.2 to 50 micrometers, and micro emulsions are 0.01 to 0.2 micrometers. Applications of emulsion means route of administration of emulsions. First is oral administration of water in insoluble liquids, for example fat soluble and vitamins. Second is intravenous administration. They are API emulsion formations, for example Taxol. Emulsions for external use, example lotions. Emulsion in aerosol can be used to produce a foam formation. Mechanism of action of emulsifying agents. When one liquid is broken in large number of small globules, then interfacial area increases. Interfacial energy associated with interface also increases. To reduce the interfacial energy, the globules of dispersed phase tends to coalesce, means merging. To prevent a collisions and to keep system stable in the dispersed state, it is necessary to add the emulsifying agents. The second is the reduction of interfacial tension. The thermodynamically stabilization, formulation of the formation of interfacial film barriers, mechanical barriers, formation of electrical double layer, the approach of electrical barriers. तीन टाइप्स के रहेंगे मैकेनिज्म. फर्स्ट इज थर्मोडाइनेमिकली स्टेबलाइजेशन, सेकेंड इज मैकेनिकल बैरियर, थर्ड इज इलेक्ट्रिकल बैरियर्स. थर्मोडाइनेमिकली स्टेबलाइजिंग इमल्शन क्या रहते हैं? इंटरफेशियल फ्री एनर्जी विच इज डेल्टा जी इन इमल्शन. तो उसका फॉर्मूला क्या हो जाएगा? डेल्टा जी इक्वल्स टू लैम्डा एल एल इंटू डेल्टा ई. सो lambda LL is the interfacial tension and approaches for the stable emulsion and reduce by adding a surface active agents. Emulsifying agents prevent the collisions of globules of dispersed by forming films around the globules. An emulsifying agent is an material that enhances the stability of an emulsion. Emulsifying agents can be divided into three groups. First is surfactants, hydrocolloids, and third is finely divided solids. The surface active agents. The monomolecular adsorptions to reduce the interfacial tension. All droplets are surrounded by a coherent monolayer of the surfactants, which prevent the collisions. If the emulsifier is ionized, the presence of strong charge may lead to repulsion in droplets and hence increases the stability. Hydrophilic colloids, the multi-molecular adsorption is there. Finely divided solid particles, the solid particles adsorption is available. Those solid particle adsorption are adsorbed at the interface between a two immiscible liquids phases to form a particulate film. Emulsifying agents. What are the mechanism of emulsifying agents? First is monomolecular film, second is multimolecular film, third is particulate films. Here is a diagram. Monomolecular adsorption. The surfactant reduce interfacial tension because of the adsorption is at interface oil in water. The droplets are surrounded by a coherent monolayers that help prevent collisions, means merging between the two droplets. Surface charge cause repulsion between the globules. Monomolecular adsorption, the combination of surfactants. Some common, usually general combinations of surfactants we use for more effectiveness. For example, the common general example is sodium cetyl sulfate and cholesterol leads to the complex film that produce an excellent emulsion. Hydrophilic twin can be combined with the lipophilic span. Varying proportions produce a desired emulsions. Either a water in oil emulsion or oil in water emulsion, both. The surfactants or co-surfactants. What are the surfactants and co-surfactants? Surfactants forms the interfacial films, and co-surfactants ensures the flexibility of interfacial layers is reduce the interfacial tension. HLP value. The type of emulsion produced depend on property of emulsifying agent. HLV value. Type of emulsion is a function of relative solubility of the surfactants. Second, rule of Bancroft. What is the Bancroft rules? The phase oil in water in which the surfactant is relatively more soluble will become a continuous phase. But the high HLB surfactant preference the formation of oil in water emulsion and vice versa. Emulsifying agents, surfactants. A system was developed to assist in the making the systemic decision about the amount and type of surfactant needed in the stable product. So what is the HLB system? HLB is the hydrophilic lipophilic balance system and has an arbitrary scales between the 1 to 18. For 1 to 3 applications are used for the surfactants. If HLB value ranges 1 to 3, the N is application anti-forming agent. If the HLB value lies between the 3 to 6, so the application will be used in the water in oil emulsifying agent. If the HLB value lies between the 7 to 9, the application used in the wetting agent. If HLB value lie between the 8 to 18, so application used in the basically oil in water emulsifying agent. If HLB value is 13 to 15, the application used in a detergent. If the HLB value lies between 15 to 18, the application should be used in the solubilizing agents. Emulsifying agents, surfactants example. For some examples of emulsifying agents, एनायनिक सर्फेक्टेंट्स. एनायनिक सर्फेक्टेंट्स क्या होते हैं? जो ऑर्गेनिक सॉल्ट्स होते हैं वाटर में और सरफेस एक्टिव एनायंस होते हैं. ठीक है. फॉर एग्जांपल अल्कलाई मेटल एंड अमोनियम सोप्स एज अ सोडियम स्टेरेट एंड पोटेशियम ऑलेट. किस में यूज होगा? इसमें ये किस में यूज होगा? ऑयल इन वाटर टाइप इमल्शन में. सोप ऑफ divalent and trivalent metals such as calcium oolate, basically used in water in oil type emulsion. Third is amine and ammonium soaps such as triethanolamine olates are used in a oil in water type emulsion. Fourth is alkali sulfates such as sodium lauryl sulfates are used in oil in water type emulsion. They are the examples of the anionic surfactants. But some disadvantage also here. Some disadvantage is irritant internally, so widely used in external preparation as long as oil in water emulsifying agents. Second is cationic surfactants. What are the cationic surfactants? Usually quaternary ammonium compounds होते हैं which have a surface active cations. वहाँ पे क्या था? Surface active anions. Here is surface active cations. The examples include cetramide and benzyl ammonium chloride. They are used in the preparation of oil in water type emulsion for external use only and must be in their ionized form to be effective. The cationic surfactants also have antimicrobial activities. Here cationic surfactants also have disadvantages like they are sensitive to anionic surfactants and drugs. Emulsion formed by a cationic surfactants are generally stapled at acidic pH. They are more toxic than other surfactants. So we used rare in cationic surfactants. Multimolecular adsorption. What are the multimolecular adsorption? Basically they are hydrocolloids. Hydrocolloids means hydrophilic colloids are different in action from the surfactants. They do not cause loading of interfacial tension. They form multimolecular layer at oil in water interface. They increase the viscosity of dispersion medium. Thank you.